My name is Matthew Graham, and this is the fourth in a series of 6 modules. This is on SQL, the basics. In this module and the next module, we will be considering the SQL, the main technology that is used to work with relational databases, which we introduced in the previous module. In this particular talk, we're talking about the basics. Next talk, we will be talking about some of the more advanced features of SQL. SQL stands for Structured Query Language. It first appeared in 1974 from IBM. The first standard was published in 1986, and there have been updates since, with the most recent in 2008. Each variant of the standard is known by SQL and then the year after it, and SQL 92 is taken to be the default standard. There are different flavors of SQL, even though they are all supposed to be attached to a standard, and those will vary from the different types of relational database management system that you are actually using. So Microsoft and Sybase use a flavor called Transact SQL, MySQL uses MySQL, Oracle uses PLSQL, and Postgres uses PGSQL. The core syntax is the same, but in the differences are ones of minor syntax or maybe additional functionality that they have over that default core standard. The variant we're talking about here is mainly featured on the core. So the fundamental argument in a SQL statement, an SQL statement that you send to the database to carry out an operation, is the select statement. And you see here the syntax, select a list of variables, a list of column identifiers that you want returned from a list of tables in the database where some condition is satisfied, some predicate, and then possibly some ordering criteria. So in our first example, let's consider that we have a table of stars. It has columns called name and constellation. The table itself is called star. There's also some columns in there of positional information, right ascension and declination, and magnitude information. So the first statement there, select name constellation from star where dec is greater than 0 ordered by magnitude, will return the name and constellation of each star for those stars which are above a declination of 0, and it will present that information in ordered in terms of increasing V magnitude. If we want all the columns from a table, we can use the asterisk wildcard. So that second statement there will return all the data from the star table where the position variable RA has a value between 0 and 90. So in those two where condition statements there, you can see where we can put in logical constraints on them. Or if we want to do between a range, we could say RA is greater than 0 and RA is less than 90, but there is this word between and that we can use in the where statement to put those together. If in our table of information we have information that's repeated, and we just want the unique values of that, we can use the distinct keyword before our selection list. So in this case, we're doing select distinct constellation from star. That will return the list of unique constellation values from that table. And in this particular format, if we want, this is MySQL variant syntax, if we just want the top 5 from a list, just to make sure that we want to see the type of data that's being returned, we would do select name from star limit 5 and ordered by V magnitude, because we still want it in magnitude case. So that is the select statement. I would argue that 90% or probably more than that of the types of queries you will send to a database will be of this format. Now, it may be that you have information that is in two different tables and you want to construct a query across those tables. That is what's known as a join. There are a number of types of joins. You have inner joins, which combine related rows, and you have outer joins, where the rows do not need a matching row between the two tables. Inner joins, the first example here, will return all the information from a table star joined with a table called stellar types, and then you give it a constraint satisfied to specify the nature of the join. So in our star table, we have a column called stellar type. In our stellar types table, we have a column ID, and what we're saying is that we are joining on those two columns so that matching values in those two columns between those two tables will be associated with each other, such that that information will be joined together. There are two ways of specifying the syntax for this particular type of operation, and these are given. One formally uses the inner join construction. The other one just says select from this table and this table where table S, aliased S, which is the star table, the stellar type column there has the same value as the ID column in table T, where we've defined T to be the alias for the stellar types table. In the outer join, we can say that we want all those which match plus all those either in the first table which don't have a match on the second table, or all those entries on the second table which don't have a match on the first table, or the join plus all the missing ones from either. And those are either the left outer join, a right outer join, or a full outer join. So it may be that you want all the columns, all the rows from one table, and the matched information from the other table as well, but you're happy to have blanks where there are not matches. And in that case, you would do either the left outer join or the right outer join as appropriate. In SQL, you have aggregate functions, counting, averaging, getting the minimum value, the maximum value, or a summation. These will work on the group of information that's defined by the where predicate or the particular column name that you've given it. So if I want to know how many rows I have in my database table, I would do select count and either a column name, or I can just use the wildcard, the asterisk, from my table name, that first operation there. Second operation there will give me the mean value, the average value of a particular column in my data. I haven't specified a where predicate, so it'll just be all the values in the column. I could restrict that with a where predicate to limit it to a smaller set of that column. If I have multi-value data, I can group by it and then apply the aggregate functions to those individual groupings. So say I have 5 or 6 different values for my stellar type column. I can group all of those of type A, all of those of type B, all of those of type K, all of those type M, for example, and then get the minimum and maximum magnitude values for those individual groupings. And that's the use of the third one example given the group by keyword. If I'm using aggregate functions, then instead of using the where clause, I might use, there's an alternate construction, which is the having clause, which applies to data. So this last example will return the stellar types, the average magnitude for each stellar grouping, and also how many are in each of those groupings, where each grouping is constrained to have objects where the V magnitude parameter is greater than 14. And that is the construction you would use for that. If I want to create a new database or create a new table in my database, I would use the create command. The syntax is create database, database name, or create table, the name of my table, and then the column name and the data type for the column as a list given. So the example there, create table star, so I'm creating a table called star, and it's going to have 4 columns. The column names are name, RA, dec, and V magnitude, and the data types associated with each of those are a variable character string up to 20 in length, and then 3 float values. A number of data types are supported. I can have Boolean properties, integer properties, real, float, double, decimal. Those can be both 32-bit or 64-bit. There are a variety of string data types depending on the length of my data type that I want to support, and then there are typically time and date data types as well that I can put in. I can specify further constraints on particular columns when I'm using my create table. I can do create table star. I say that the name field has to have a value. It cannot be nullable. It has to have a value associated with it. If a value is not given when I'm putting data into my database, a constraint will be raised. I can put a default value for a particular column. In this case, in the RA column, I'm saying that it's taking a default value of 0. And there are further constraints I can put on. Particularly useful feature is those of keys. Keys identify important columns in a particular table, and they will typically be used to identify a column in one table that I want to link to a column in another table that will be used for the purposes of doing joins. A table typically normally has what's called a primary key. This is a unique identifier for a row, and automatically has to be not null. When I'm creating my table, I can identify the column or set of columns that I want to be used to construct the primary key by using the particular syntax given here. So in this case, I'm saying that the name column will be the primary key. This is automatically a clustered index on this particular table. It means that when the data is written to disk on the computer, the DBMS will make sure that sequential records according to the ordering of the primary key are put next to each other. So you will always get fastest retrieval from your primary key or queries against your primary key. I can associate 2 columns in 2 different tables with each other by creating a foreign key constraint and saying this is a formal constraint, and that will help for doing joins involving those 2 tables. It also means that if I'm putting data into the database, then I need to make sure that I'm putting the relevant information in, because it will check keys if they exist between those tables to make sure those values are put in for that data. If I want to see how many tables I have in my relational database, what the table names are, I do the show tables. If I want to see if I have indexes on a particular table, which columns may be indexed, what type of indexes there are on those columns, I'll do the show indexes and the table name. If I've done something wrong by putting data in or an operation and I'm getting a warning message, I can see what the warnings are by show warnings. If I'm looking at a particular table and I cannot remember what the structure of the table is, there's this describe and then the table name operation, which will give me the table structure then, and I'll be able to see what the columns are and what the column data types are. If I want to put data into my database, I use the insert keyword, insert operations. So the syntax is insert into table name and then values and the values. So if I'm putting all the values for a particular row in, the first operation, insert to my table star, the values, and then the the values for each of the columns in the appropriate order: Sirius, RA, DEC, magnitude. If I only want to put information in for a certain number of columns, then I need to specify what those columns are before the values keyword, so that second operation shown there, insert into star, and it's only the name and the V magnitude columns that I'm putting values into. In this case, it's Canopus, and minus 0.72 will go into that. I can populate a table with an insert statement as the result of having done a select operation on another table or set of tables. So there's a query that I'm going to run, which is doing several joins on several tables. I write that as a select statement, and then I can, by making sure that the select statement is returning the correct values, use that as the input into an insert statement and combine the two and run that as a single operation. If I want to do a bulk load of data into a table, I can, in MySQL, use the load data statement, and the syntax here is as specified. I'm loading data in file, and then I specify what the path to the file on my hard drive is, into table with the table name, which has been already created with the appropriate fields. Fields terminated by a delimiter. That's saying that the fields in the table that I've got on my hard drive are separated by a particular syntax. So in this case, load data in file, I've got a comma-separated variable data file into table star. The fields are terminated by commas. Similarly, I can put data out. I can dump it onto a file on my hard drive, select a star into out file, fields terminated by columns from star where V magnitude is greater than 16. So that will select everything from the table star where V magnitude is greater than 16 and write it into a comma-separated variable file on my hard drive. Finally, if I want to get rid of information, I can do a delete statement. Delete from table name where some condition is specified, that where condition again. If I want to get rid of all information in the table but keep the table empty, I would do truncate table name. If I want to completely get rid of the table and all its contents, then I drop the table name. So the first example there, delete from star where name is Canopus, will just get rid of that row. If I want to get rid of all stars where the name begins with the letter C, and there's maybe an N in it, I would do that second syntax. This is making use of the like construction in the where predicate. Or if I want to specify a range, delete from star where V magnitude is greater than 0 or DEC is less than 0, Boolean construction. Or I can use the between construction to say I want to get rid of that information from the star table where the V magnitude is between a particular set of constraints. Finally, the update statement. If I want to update information in my database, I can do update table name, and then I set the column value to a value name where condition is met. So update star, if the V magnitude is wrong by an offset, I can do a global update by saying update star set V magnitude equals V magnitude plus 0.5. I can do an individual entry. I'm going to change the V magnitude for the row where the star is called Sirius. Update star set V mag equals 1 minus 1.47 where name like Sirius. Or I can do an update as the result of a join with another table to maybe update a column with information from that other table. In this third example, update star, where I'm doing inner join. And when you're doing the update statement, you need to use the inner join syntax. And you specify the two table columns that are being used, and then say set the V magnitude in the star table equal to the magnitude value in the temp table. And that is the end of this module.